Hello, everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Our topic today is why use BGP. In short, how fast BGP is. We mentioned that in the last video. What is BGP involved? And the basic concepts of BGP. What can it do? So what is the fast manifestation of BGP? We can look at it in detail. In this picture, for example, it's the network environment of IDC. IDC is called Internet Data Center. Internet Data Center. What is the main activity in the data center? It mainly hosts the server. For example, we often visit Baidu's server. Its website is hosted on a server. It's like you have an app on your computer. The server is located in the data center. We all know. In addition to the necessary operating environment, it also has bandwidth access. Publish the server to the internet, and then you can access it. That's the first condition. Let's say this picture right here is IDC. A network similar to a campus network. There's an exit device here right now. The exit device inside is the IDC. It can also be understood as our daily use. The intranet of the enterprise network. Except it's full of servers. Like private data centers. The main thing is to do the hosting server business. It has all of the company's servers. It guarantees its efficient bandwidth. Ensure the stable running of the server. Whether it's a Tencent-owned game or the website of JD.com. All of these sites have servers. They're servers. In most cases, there is a self-built IDC. Like AliCloud, Baidu Cloud, and Gingdong Cloud. They just put the servers in the data center. Now let's talk about how BGP is fast. Take for example. People often download some software on website. Through a third party's website. It can feel particularly slow when downloading. Using telecom's broadband, for example, could be fast. It's slow to use moving ones. Of course, this is not absolute. This is the same as what we talked about today with BGP. It has something to do with it. Usually for data centers. It and the base of the enterprise net price. To compare. Like this export device. Usually, these are the two default routes. Or the default route. No matter where you're going. You could go left or you could go right. This is the server. That's what it involves. Let's say I have users here. The user accesses the server inside here. Then the server has to send it back. Take broadband, for example, through telecoms. Visit your internal server. Request download. In the case of the server, you have to send data back to it. The user accesses the server and it doesn't have a lot of traffic. And for the server to transmit to it. For example, downloading software for a video. Some large data files and so on. So in the download process, the speed of BGP has a lot to do with it. So let's think about it. Let's say it's accessing your server. You have to send data back to it. Let's say it accesses you through telecommunications. Data is now recycled through Unicom's network. It's not going to be fast. Because it doesn't matter which carrier. It's sure to protect its own users' traffic first. You go the telecom route and it's definitely the fastest. Because the route of telecommunications is the shortest. You do the telecom broadband, go Unicom. It doesn't reach the user directly yet. Because it does telecommunications for broadband. Data must be sent from Unicom to telecom first. And then from telecom to the user. So here's the thing. The data has been traveling for a long time. The natural speed is slower. It takes longer. Let's say we can do it accurately through the telecom. If it is a Unicom user to access the server, download some files, and then it's sent back through the link. Is that going to be fast? It will improve the user experience. So how does this happen? If it is a traditional enterprise network structure, two default routes are sent. One goes to telecom and one goes to Unicom. Simply put, the default route. Wherever you go, it's right. It doesn't achieve path optimization. Because for export equipment, you can go either way. But it doesn't know. Users in the end is to go to telecom side of the fast. It's better to go this way. So you don't know where the user is, right? We can run BGP. For example, this equipment and telecommunications. There is also BGP running between Unicom. All routing entries of telecom. It's going to be passed on to this device. The routing entry of Unicom. It's going to pass it all to this router. And for my router, it's like having all the details. What is a detail? Just make sure that every path is clear. Go closer to the left or closer to the right. Let's say you go to Beijing. Which direction is it coming from? Chengdu or Shanghai will eventually reach Beijing. But it has to be faster from somewhere. You have to know the route to be okay. BGP does this. Telecom passes its corresponding route to you. Unicom passes it to you. So you have a detailed list of items. So when the server sends back data, once the data is sent to this device in the middle, as this device left and right. Subscribers do telecommunications for broadband. There must be a telecommunication route. Users do Unicom broadband. It has a connection route. So it can be very explicit. By receiving a clear route to implement the path selection. This allows for path optimization. In this way, the concept of fast BGP is implemented. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.